All right, well, let's take one additional look at looking at indirect proofs for algebraic proofs, and this has to do with number theory. And before we begin this and look at what we've got here, let's, in number theory, an even number can be represented by 2k, where k is equal to any integer, and an odd number can be represented by 2k plus 1. Again, for k, for any integer of k. So let's look at what we have here to consider. All right, it says write an indirect proof to show that the square of that if the square of an integer is odd, so if the square of an integer is odd, then the integer is odd. So let's put this first in a given statement and a conclusion. So we can say that given x squared is an odd integer. So if the square of an integer is odd, the integer is odd. So x squared then is an odd integer. And our conclusion then is that x is an odd integer. But remember, we're doing indirect proof, so we're going to come up with an assumption that is opposite of that. And that is the indirect proof that the integer is even. This means that x equals 2k for some integer k. And we're employing this part of the number theory. An even number we can represent as 2k. Now, we can test this theory, this indirect proof. So we can say that x squared is equal to 2 squared. Okay, well, let's see. If that's the case, then we could say that x squared is represented by 2 times 2 squared. Well, let's see. 2 times 2 is 4. This is an even integer. And 4 squared is 16. Okay, well, that's not odd. Let's say that 2 times 4 squared, 2 times 4 squared, no, it's 2 times just, excuse me, it's just 2 times 4. We'll go back to here. Let's erase that. All right, so 2 squared is 4. 2 times 4 is 8. No, I'm sorry, I did it wrong again. I had it right the first time. We're going to put this whole thing, so it's 16. All right, get back on track here. So then we got 2 times 4. We're substituting 4 for k, another even number. Well, 2 times 4 is 8, and 8 squared is 64. Fair enough. And well, let's do one more. If we substitute 6 for k, 2 times 6 squared, let's see, 12. 12 squared is 144. So we used even integers based on our indirect proof, and we squared that, 2 times the even integer squared, but 16, 64, and 144, none of those are odd. So the square of those even integers is not odd, it's even. And so then we can come back here and say that since the assumption being the integer is even, the assumption that x is an even integer is a contradiction of the given statement. So the given statement is x squared is an odd integer, and we saw that was not the case in this, nor this. Okay. Then the original conclusion that that x is an odd integer, here's our original conclusion, must be true. using indirect proofs in number theory. Now, it can't get much more exciting than this. I hope you really can contain yourself. I know it's going to be difficult, but I have confidence in you.